Right, today I'm starting off a series of videos to cover the issue of consonant analysis. This has been prompted by somebody who actually asked me to instruct them with regards to it, and they were looking for resources on the internet which would actually help them. And what I explained to them was, well, I'm the first person to sort of like formulate it, so it doesn't exist anywhere else. So this short video is going to be on the subject of differentiation, i.e. how one thing is different from another, and it's probably the biggest theme that's around us. You know, people talk about elephants in the room. Well, differentiation is probably the biggest one, and it's not only what makes one thing different from another, but it's what makes the world go around and makes people go out to work and makes people, you know, I don't know, go crazy over music and gold and all of these things. It's because there's some level of differentiation, or greater or smaller, you know, and some slight threshold that something goes over. And as a result, you know, things work, the earth turns, and, you know, like I said, you know, people enjoy themselves. So what I intended to do was explain how things came from a unitary point, as they tell us, right up to what we see today, and we are seeing at the moment actually. And if you look around you, you know, you're not looking at the screen. What I postulate is that everything is continually differentiated. In other words, it's continually being differentiated as against itself and against everything else, and it needs to be to exist. And that's borne out by the fact that if you've got something which is differentiated, what that means, it's definite. You know, it's a definite thing. You can see it. Yeah. So therefore, the thing which is doing the differentiating must be something which is not definite. In other words, you don't know exactly what it's doing from one minute to the next. You cannot predict, by virtue of the fact that you can't see it, but it must be there because we've got things that we can see, you know, like this Rubik's Cube that I'm going to use in a second. Or indeterminate, we could say that it's indeterminate. In other words, we can determine what things are around us because they're differentiated. However, the very fact that they exist and they're not moving themselves, I'll come on to that in a second, lends itself to the notion that they must be being differentiated by something which is indeterminate. You know, only something which is indeterminate can affect something which is not. Otherwise it would be determinate. And the principle that I said I was going to go on to is essentially that nothing can move faster than itself. You know, so anything you can see around you, or witness, or perhaps not witness, it can't move faster than itself. And you might think this is like a bit of a strange concept. It's a very important one. It's a very, very important one to highlight the fact that somebody is moving everything. You know, this indeterminate thing or force, whatever it is. So I'll explain it like this. If you imagine, I'm going to use this Rubik's Cube. This Rubik's Cube, it's moving now, isn't it? Imagine it's like a rocket or an airplane moving through space. Yeah? It cannot move beyond itself, can it? It can't go faster than itself. Yeah? It only has to go at the speed that it's going. Yeah? So imagine that it's still now. You know, it hasn't actually set off. Yeah? Can it move faster than itself? Obviously not. It can't move faster than itself because it stood still. So if it stood still here and it's ready to set off, what's actually moving it? You know, and what you've got to take into account is that nothing can move faster than itself. Everything's the same. It's all matter. Nothing can actually move faster than itself. So if everything originally is at a standing point, what's actually moving everything? Yeah, so this lends the notion that there is a creator who created everything and he's actually moving everything and differentiating everything. And it hasn't stopped, it's still doing it, it's still happening because you can still see things and witness things. And I'm talking to you now and, my hands are moving around and, things are happening. Yeah. The thing is, how does it actually all happen? It all seems so complex and difficult, and scientists are studying it and trying to understand and get inside things. And I'm one of these people that I always try to fit things together, and also I like to do it simply. And obviously, I start from where I am and try to work to where I'm going. So and I always try to work with win-win. That's the type of person I am. So the way I would explain it is that based on the fact that we had a starting point, which was what they call is the Big Bang, and we've got where we are now, we've got chickens and noodles and people crossing the road and things happening on Friday and all sorts of things. How did we actually get to this stage? And I say it's very simple. What happened was, this was the one unit of creation that God created. And because he knows everything and he knows what everybody wanted, he was able to see that and then know in advance what calculation to perform, or what ratio to differentiate everything on in order for that to occur and to continually occur. And I say it's the golden ratio, because you can see it popping up all over the place, And the one example I always cite is that you never go anywhere in the world and you see a square door. You never see a door that's like that shape, square. You never see that. You always see a door which is rectangular. And you think, well, why is that? Why do we see rectangular doors? Because, anybody who's moved house knows it's better if you have a square door because you can get things through more easily, like settees and so forth. But we don't. We struggle with rectangular doors. Everywhere in the world, there's nowhere in the world that I know of anywhere, I might be proved wrong, they actually have square doors, but everywhere I've been, no, they don't seem to. And it goes back to this thing that it's inbuilt into us to actually accept this ratio, the golden ratio. And we see it pops up around us all of the time, like even behind me. The rug that's up there, that's actually, it's pretty much on the golden ratio, 1 to 1.6 to 0.618. So if you imagine like this, so the differentiation at the beginning was one unit of creation. Now for this to continue to exist, because it's not absolute, it must be differentiated again. Yeah? And this differentiation would occur not only here on the level that I've shown you, but in each one of these squares. And then each one, if you imagine each one of these squares is actually the same as this, and then each one of those, and each one of those, and each one of those, and they would all interact with each other, yeah? And then in the blink of an eye, unfathomably short period, you would get, you would basically get atoms and things and whatever you flying out. Take that on an infinite number of times, yeah, and you basically get what we've got around us. So it's basically, it looks complicated, but it's not. It's the same ratio that's been at play, and differentiation has occurred so many times, an incalculable, incomprehensible number of times, and is continually doing because I'm still moving, such that everybody will get what they want, and things move, and perhaps that explains why the universe is expanding at such an exponential rate, which is, I believe, 2 quintillion meters per second. Because the point is that if what I'm saying is correct, the principle of differentiation is correct, that means that a point, once it's been differentiated, can never exist in the same place where it exists at the moment, where it existed, when it was last being created, by virtue of the fact that it wouldn't be differentiated, because all of the points in existence have to be different, because again they're differentiated. So things can never be in the same place. That like I said, that would explain the expansion of the rate of expansion of the universe. So that's my initial talk with regards to differentiation, which is the crux of all of this, yeah, and it underpins my unified theory, and also goes down to consonant analysis, you'll see when I sort of like produce my videos. So I mean, thank you for bearing with me. I'm just doing this off the top of my head. It's a bit of a rambly video, but I do ramble anyway. I've got Asperger's syndrome. I hope you found it informative. You know, if you've got any comments, questions, criticisms, what have you, you know, put them in the space below, essentially. And you know, it's just my idea, you know, but it's borne out by consonant analysis. You know, consonant analysis is one of those technologies which actually proves this or points strongly to this as an indication that what I'm saying is correct. And if I'm not, no problems. You know, we can all carry on and, you know, drink our tea. So thank you very much, and hope to see you in the next video, because I've got to get off for work now.